In this video, we're going to take a look at solving equations involving logarithms and exponential functions. So if we just jump into the first question here, we're asked to solve the equation of log of 3x plus 2 base 2 is equal to 3. So where do we begin here? Well, we need to understand that we're working in logarithmic form here. So what we're looking for is the value of x. So to get that value of x, we need to go from logarithmic form to exponential form. Okay. Now, there's nothing we can do here with this logarithm. We can't combine it with any other logarithms. We've just got a single logarithm, so we can go straight into converting here. So if I've got log of 3x plus 2 base 2, okay, so we're working with base 2 here, and that's important. So what I'm going to do is take everything now to exponential form here. So once I take exponential form of a logarithm, they cancel out because they're the inverse of each other. So in that case, on the left-hand side, we're just going to get 3x plus 2. Okay, so we get 3x plus 2. And that's equal to 3 on this side, okay, for our original equation. So once I take now exponential form here, because we're working with base 2, this becomes 2 to whatever this is. So if this is 3, it becomes 2 to the power of 3. If our base was 4, that would be 4 to the power of 3. If this was 5, it would be 2 to the power of 5. So you can see how that changes things, okay? So 2 to the power of 3, that's 8. So what I've got here then is 3x plus 2 is equal to 8. And at this point here now, this is a nice straightforward GCSE maths equation. So subtract 2 off both sides. So we get 3x is equal to 8 minus 2, giving me 6. And then finally, we just divide both sides by the coefficient here of 3. So 6 over 3, giving me 2. And there we have it. So that's our solution to the first question. Moving on to the next one here then, where we're asked to solve the following equation. So we want to give the answer to 3 significant figures. So we'll come to that at the end. So here now, what I've got is something in exponential form. Okay, so I've got 3 power of x is equal to 20. Now straight away, hopefully you might recognize that our solution here must be between 2 and 3 for x, because 3 squared is 9 and 3 cubed is 27. Okay, so if we want something in between here, so we want 3 to the power of something is equal to 20, it must lie also between this power here of 2 and 3. Okay, so that kind of gives us a bit of an idea to get us started. Now, because here we're in exponential form, okay, we've got an exponential function. What we need to do is convert to logarithmic form. So we're always just converting between either exponential form or logarithmic form. So in that case, what I'm going to do is take logs of both sides here. Because this base is 3, I'm going to take log base 3 of both sides. Now, once I take log of this exponential here, they'll cancel out. Remember, they're the inverse of each other. I'm just going to get left with x here. So on the left-hand side, we're going to get x. And on the right-hand side here, I'm going to get the logarithm of 20 base 3. I get log 20 base 3. And at this point here, we just need to put this into our calculator and we're going to get x. Okay, so put this into your calculator here. And what you should get, if you do this correctly, so log 20 base 3, so it'll give you 2.726833 and so on. But we only want our answer to 3 significant figures here, so x is going to be equal to 2.73 in this case. Okay, so 2.73, and that's our solution to that question. Like we can see, it does lie between 2 and 3, so we're happy with that. Okay, and there we have it, so that's our solution to the second question. Moving on to this one here, where this time now we're in logarithmic form. Now this one's a little bit more complicated than the previous example that we saw in logarithmic form. And the reason for that is because we have 2 logarithms here. Okay. Now what we need to do here is go back to our laws of logarithms, and we want to convert this to a single logarithm. So because we're subtracting here, this becomes a division rule. So I've got log of x plus 8 over x minus 2, because we're subtracting, it's a division law. I've got x plus 8 over x minus 2 here. Remember, the base is 3. Okay, and we can do this because they have the same base, base 3 here. And all of this is equal to 2. Now, we don't want to be working in logarithmic form here, so what I'm going to do is take the exponential function. I'll change both of this now, or both sides, to exponential form. So in that case, once I take the exponential of the left-hand side here, because it's a logarithm, they'll cancel out. So I'm just going to get left with everything inside the bracket here. So on the left-hand side, we get x plus 8 over x minus 2. On the right-hand side here, because our base is 3, this becomes 3 to whatever this is. So in this case, 3 squared. Okay. So that's going to be 9. So I get x plus 8 over x minus 2 is equal to 9. Multiply both sides now by x minus 2. So we get x plus 8 is equal to 9 lots of x minus 2. Multiply through now by 9 on this side anyway to expand the bracket. So I get x plus 8 is equal to 9x minus 18 here. And we just need to solve this now. So in this case, I'm going to subtract x off both sides. So I'm going to get ax here and then add 18 to both sides. So I'm going to get ax is equal to 26 and then divide by the coefficient of x here. So if we just do that up here, then x is going to be equal to 26 over 8. We can write that as 13 over 4. And because 13 is prime, we can't do anything further with that. Okay, so there we have it. So x is equal to 13 over 4. And that's our solution to question 3. I'm moving on to the very last question here, just another example where this time now we have it in exponential form or as an exponential function. So we just want to solve this equation again and again, giving our solution to 3 significant figures. So we've got 4 to the power of x minus 1 is equal to 60. So where do we begin here? Well, because we're in exponential form, we need to convert this now to logarithmic form. So if I take the logarithm now of this left-hand side here, because this is an exponential function, they cancel out, they're the inverse of each other, and I'm going to get left with the power here. So therefore, we've got x minus 1 is going to be equal. And because this is 4 here, we're taking the logarithm with base 4, so I'm going to get log 60. So log 60 base 4. Okay. Now we want the solution for x here, so what I'm going to do is add 1 to both sides, and that will give me x. So x is equal to 1 plus log 60 base 4. Okay, that would be our answer in exact form, but what I want to do here is just give the answer to 3 significant figures. That means I'm going to have to put this into my calculator now. So if you put this into your calculator and round that to 3 significant figures, what you'll get here is 3.95 there. Okay, and there we have it. That's our solution to the very last question, and that brings us to the end of this video on solving equations involving logarithms and exponential functions. In the next video, we'll take a look at introducing the natural logarithm.